on this part of math, we are going to talk about numbers. What is the classification of numbers? How we classify numbers? We can classify them as we know: whole numbers, integers, rational numbers, irrational numbers, real numbers, imaginary numbers. These numbers we're going to talk about this part. And in the next part, we're going to talk about properties of numbers, like properties like commutative, associative, and distributive and identity property. And next part, we're going to understand the multiplicative inverse as part of these properties, and we're going to talk about the number line and parentheses and brackets and what's the difference between them in intervals of solutions. Okay, numbers now, as we know, people when they were first in the past used or started using math, they used like the numbers that we know, like a child whose age is 3 or 4 years, he can start just saying the numbers 1, 2, 3, 4. If you tell that person what is 3.5, he doesn't know, right? So that means the number that as people start using them in their nature, we call them natural numbers. And what are natural numbers? And they are numbers like what? 1, 2, 3, till positive infinity. So this one now we call it what? Natural numbers. Then after they used natural numbers, then they created a 0. Then they added a 0 there. So that means now these ones becomes whole numbers. So whole numbers now what they are? 0 and 1 and 2 and 3 till positive infinity. And as you see now, natural numbers, which one? The previous group is part of the new group. Thank you. Then what is the third one? Then people then started using what? Negative numbers, but they are the same. So these ones now, the previous ones, 0, 1, 2, 3 till positive infinity, right? And here they started using what? -1, -2 till what? Negative infinity. Till negative what? Infinity. And this one now what is called integers. This one is called integers, and its letter is Z. Good. And integers are very important. So when they tell you in a sentence that the answer is integer, that means no decimals are there. Until now, as you see, no decimals are there. Okay, then what comes after integers now? What comes after integers is in rational numbers. And what rational numbers now? Rational numbers are any number, you can write it as a fraction. So we call it Q, quotient, like a quotient as fraction. And when you divide it, its decimal will be either repetitive decimal or terminated decimal. How? For example, now when I tell you a number 3, is it quotient? Is it rational number? Yes. Because now it means 3.0, but we write it as 3. So 3, any number, any whole number, any integer is also part of what? Of rational numbers. Thank you. Okay, if I have a number like 1.25, you see, this one now, it is decimal, but its decimal now is terminated, 1.25, and that's the whole number. That means no decimals were rounded. So it's only 1.25. So this one is what? Is rational number. Okay, if I have 0.33 like this, and this one is repetitive, 0.3333, also this one is what? Rational number. Okay, if I have 1/2, is this one is rational number? Yes, because 1/2 when you divide it, it's going to be 0.5, then it stopped. Terminated decimal, so this one is what? Rational numbers. You understand now what are rational numbers. And as you see, all the previous groups are classified as rational numbers. So how can we write them now? How can we draw them here? This one now, we call it what? Natural numbers. That came first. Then a broader group came. It's called what? Whole numbers. That means with 0. Then a broader group came, which is what? Which is what? Integers, which is what? Z. Then a broader one came. I'm going to make it red here. It is what? It is quotient. It is what? Rational numbers. So that means, as you see, natural numbers is part of whole numbers. Whole numbers are part of what? Of integers. And integers part of what? Of Q, which is what? Rational numbers. Okay, now what is the numbers that are irrational? We call them I, and keep that in mind. Okay, numbers now here, this one here. Classification is number 1, and here's number 2, and here's number 3, and here's number 4. And now we go here to talk about number 5, which is irrational, and it is I. Irrational, that is what? I. Irrational numbers is like pi. What is pi? Pi, as we know, it is 3.14, but is it ended? Or 3.14 and after it numbers? Yes, it's numbers. And it's none, it's not, it's neither terminated nor repetitive, right? So in this case, we call it irrational. So that means any decimal. If you write like 2.3253 like this, if you see, if you complete and 2 point these numbers after the decimal, as you see, numbers and different numbers, and they go to for long way. In this case, we call this number what? Irrational, since its decimal is not terminated and not repeated. That means it's not just like 32 and 32 is repeated, or 333 repeated. That means it is just different numbers. In this case, we call it what? Irrational. Good. Now this one, now the 5th group, it's the group that the previous 4 groups are not part of it. Okay, now then number 6 here, group that is number 6, which is real numbers, and its letters what are. And real numbers, it is rational numbers plus what? Plus irrational numbers. And rational numbers, as we know, which is group number 4 here now, it belongs all the previous ones inside it. So that means if I have a box here in general, as you see, if I have a box here, and inside it, as we said here, this is natural numbers, and if the bigger one, as we said, it is whole numbers, then comes integers, which is Z, and this one now, which is the pink one, is called what? Rational numbers, which is Q. Okay, if there is now another one, another group that is here, you see, another group here, that is what? Irrational numbers, which is I. All these ones now, all this box now, called what? Real numbers. So real numbers, as you see, it includes rational numbers and irrational numbers. That means any number now, 0.5, 0.55522, 0, negative 0.5, any numbers like this, all of them, we call them real numbers. Okay, is there other part that is not real number? Yes, look, what does it mean? Like, okay, this one is number 7, which is a number that is not real. A number like when I tell you now, negative or a square root of root 1. A square root of negative 1. Is there a number that it's a square root, or it has a square root like negative now? Is there a negative number that it has a square root? No. Because now what is a number I multiply it by itself, I get negative 1. No real number that can multiply it by itself, like we know, square root of 4, square root of 4, as we know, is 2. Because the 2 we multiply it by itself, we get the 4. So here now, is there a number that is x and we multiply it by itself, we get negative 1? No. In this case, we call it I, which is what? Imaginary number. And in this case now, we understand exactly what are the numbers and how they are classified. And you remember these letters as well, these letters, so when it comes, you understand which letter they are talking about in the questions. Good. We'll move now to the next point. The next point is, in general, if we are talking about integers or numbers now, some properties we have them. And these properties, number 1, we call it what? Commutative property. And number 2, we call it what? Associative property. Number 3, we call it distributive property. And number 4, we call it what? Identity property. Okay, what does these properties mean here? Commutative property, that means if I have 3 plus 5, I can rewrite it as 5 plus 3. And this one is called what? Commutative property. If I have 3 times 5, I can write it like 5 times 3. So this is what? Commutative property. And in vectors, for example, if you remember, like as an example, like in vectors, which is cross multiplication in vectors, it's not commutative. So that means A times vector A times as cross multiplication for B does not equal what? B as cross multiplication for what? B vector times what? Times A. This is just an example that commutative is not working there, but no need to remember it. It's related to vectors. Good. Here now, this is now we understand commutative. Okay, what is associative here in this case? It means if I have 3 plus 5 plus 2, I can rewrite it this way. I can rewrite it 3 plus 5 plus 2. You see? And also it's still the same. That means I can either start by adding 3 plus 5, then I add the 2, or I can add first the 5 plus 2, then I add the 3. In this case, the result will be the same. This one equal to what? Associative property. Okay, what is distributive property? Distributive property is when I have 3 outside the bracket and I have here x plus 2. Then I multiply what is outside the bracket by what is inside. So that is going to be 3x plus 6 times 2 is, 3 times 2 is what? Is 6. So that means in this case now, this one is called what? Distributive property. Okay, what is identity property? Identity property is like when I tell you now 3 times 1, it will give me what? 3. So that means identity, it means when I multiply by 1 or when I add 0. And 3 plus 0, it's going to give me what? 3. So this one is called what? Identity property. And we understand just here, what does it mean? Multiplicative what? Inverse. What is here? We're going to understand something what is called multiplicative inverse, but you're going to take it as a new page. What is multiplicative what? Multiplicative inverse. What is multiplicative inverse? Multiplicative inverse, when I tell you 5, I have a number 5. What is its multiplicative inverse? Multiplicative inverse is a number that when I multiply it by 5, I get 1. So what is the multiplicative inverse? I write it here. What is the multiplicative of 5? 5 times what? It's going to give me 1. It's going to be the inverse of this 5. Just write it as 1 over 5. Okay, when I tell you what is 0.2, what is its multiplicative inverse? That means the number I multiplied by itself, I get 1. Get a number that I multiplied by its multiplicative inverse, I get 1. So 0.2, what is its multiplicative inverse? It's going to be 1 over 0.2. And 1 over 0.2, it means 5. So 0.2 times 5, it's going to give me 1. So 5 is the multiplicative inverse of 0.2. So you understand now what is multiplicative inverse of numbers. Okay, if we take just examples now of what is multiplicative inverse. If I tell you now 1 over plus x plus 3 is the multiplicative inverse of 8. Find x. Find x. How you find x now? So since this one now here is the multiplicative of the multiplicative inverse of 8, and as we know, what is the multiplicative inverse of 8? It is 1 over 8. Good. So that means this one now is the multiplicative inverse, and it's given for me as 1 over x plus 3. So that means what here? 1 over x plus 3, it has to equal 1 over what? 1 over 8. Then what x here should be? X plus 3 has to be 8, right? So that means x in this case will be what? 5. Because 5 plus 3 is going to be 8. So in this case, you get 1 over 8 equals 1 over 8. That means what's the number that make now these fractions equal? Either you do it like that, denominator equals denominator, or you flip them upside down, and you do it. And I hope that is clear now, and you understand how is or what is what a multiplicative inverse. And if I have a multiplicative inverse, how can I write that as an equation? Okay, we're going to take another example as well here, just for multiplicative inverse. Okay, for this example now, if I give you now x minus 3 over x, this value now, or this number is the multiplicative inverse of what? Of 4x over 4x plus h. And it will now find x. You can pause the video and try to solve it to find what is x. So here now, this is a question, and this number is the multiplicative inverse of this one. And I remember what is the multiplicative inverse. That means if I multiply a number by its multiplicative inverse, the result will be 1. That means if I multiply this number, which is x minus 3 over x, if I multiplied it by, if I multiply by 4x here over 4x plus h, that means it's going to give me what? 1. This is the idea. Good. How can now I just, if I have a fractions, 2 fractions, and here multiplication up, and here multiplication down, in this case, you can cancel. So that means I can cancel this x by what? I can cancel this x by this x. What will be left? Up x minus 3 times 4. Multiply me now the 4 by inside. When you multiply the 4, this is distributive. You're going to multiply the 4 by x and the 4 by negative 3. So that means it's going to be 4x minus 3 times 4 is what? Is 12. Now what is left in the denominator is 4x plus what? Plus h. And the right side equals what? 1. As long as the right side equals 1, so the left side has to be 1. Good. And left side has to be 1 when the left side, when you have a fraction, when the fraction can be 1. If the denominator equals the numerator, right? So that means that the numerator, which is 4x minus 12, it has to equal what? The denominator, that is what? 4x plus h. So denominator equals what? Numerator. As you see here, you can cancel this 4x by this 4x. When you send 4x, one of them to the left side, that means it's going to be here. Negative 12 equals what? Equals h. So x equals what? I mean, h equals what? Negative 12. This is one way to solve. Another way to solve it here, you can solve it in another way. Okay, another way to solve it, look, a number and its inverse, right? And we know what does it mean, how is the inverse? The inverse is just to flip or to make the whole number in the denominator. To make the number, okay. We're gonna solve it in another way. This one here, what is its inverse? Its inverse is you flip it upside down, right? You flip it upside down. For example, 5 over 1, what is its multiplicative inverse? It's gonna be 1 over 5. So that means you flip it, this is the multiplicative inverse. So that means now, if I flip this one here, if I flip it just to be x, and here x minus 3, it's gonna be the multiplicative inverse. And the multiplicative inverse is given for me, that is this number, right? So that means they are equal. So here is 4x, and here is 4x plus what? Plus h. This is another way. Now, if I divide both sides by x, if I divide here, both sides by x, so what will happen? This x will go by this x, right? What will be left? On the left side, I'll get 1 over x minus 3, and on the right side, I'll get 4 over what? 4x plus what? Plus h. In this case, you can make cross multiplication, even if in the previous step, even in this step, you can make cross multiplication, it works. So I'm going to make here cross multiplication, what I'll get 4 times x minus 3, which is 4x minus what? Minus 12 equals what? 4x plus what? Plus h. So it's going to be the same idea. 4x will go by 4x. So h equals what? Equals negative 12. I hope that is clear. Now we understand how we make applications, or how can we do applications for the multiplicative inverse and for the properties of numbers. Okay, last point on this part, we're going to talk about what's the difference of parentheses and brackets. Okay, if I have a number line, and I give you here x greater than 5, and here I tell you x less than or equal 3. Okay, how can I draw these ones in a number line, and how can I write them as intervals? As we know on the number line, here, and we know that the number line here is a 0, and here is 1, 2, 3 till positive infinity, right? And here negative what? Infinity, and here is negative 1, negative 2, and so on. Okay, if now just to make the number here easier, we're gonna write it like what? Like just to make it smaller for to fit the graph that we did. So here we're gonna write it like 2. Okay, now x is greater than 2. When I tell you x is a number, but this number is greater than 2. What possible to be x? X greater than 2. So that means can it be 2? No, because they said greater than 2. Greater than 2, that means 2 is not there. X cannot be 2. It's greater than 2. That means it can be 2 point a number like 2.1 or 2.001. Any number that is greater than 2. So that means I go to the 2 here. Look, I go to the 2 here and I draw an open circle. Now I go right side or left side to represent X. X is greater. Greater, that means go to positive infinity. So that means now, as you see, number 2 is a hole there. It's a circle. It means that 2 is not included in the solutions of X. Okay, now how can I write it as interval? It starts from the 2, then it goes to the positive infinity. And we start writing the interval by the smaller number than the greater number. And now since the 2 is not included, we draw what? Parenthesis on the 2. We draw parenthesis. Then also with the infinity, we draw what? Parentheses. Okay, to understand it more, we'll go to the right side. Here now, if we draw the number line, and here is 0, 1, 2, 3, and here is 4. Yet then here is, as we know, -1, -2, and so on. And here is negative infinity, and here is what? Positive infinity. Okay, X here less or equal 3. That means X can't be 3. Yes, it can be 3. X can be 3. Thank you. So X existence, it can be 3. So we draw here a closed circle. Closed circle, it means here the 3 is included. Now we go right or left. X is less than 3. Less than 3, go left, right, to the negative side. But right, if it is greater than 3, you go to the right side. So then I draw what? I draw this way. So that means this one here, 3 is included and negative infinity. How can I draw it as interval? When I write it as an interval, I start by the smaller number. What is the smaller number here now? Is it the negative infinity or the 3? The negative infinity. So you write negative infinity, and the negative infinity we write with it what? Parentheses. So this parentheses now, it indicates like open interval. And to the 3, which is the greatest number. Now on the 3, I write what? Brackets. You see, I write what? Bracket. The bracket means the number which is 3 is included in the solution of this inequality. So the 3 here is included. So from negative infinity to the 3. And I hope that is clear now how you understand in understanding what is called the parentheses. And when we write it, when we write it, and when we write what? Brackets, and what do they mean as included or not included. Thank you so much. See you in other videos. Goodbye.